All right, in this video, we're going to talk about balancing of chemical equations. So in the introductory portion of the lectures about chemical reactions, we know that um, atoms in a chemical reaction are neither created or destroyed. So all the number of atoms that I have on the reactant side in different molecules, I will have the same number of atoms on the product side, but they're going to be rearranged. They're going to be in different compounds, rearranged, but the same number of atoms. So you may have noticed on this particular reaction, we don't have a balanced chemical equation. If you go through and look at it, I don't have the same number of atoms on each side of the equation. So we want to learn today how we go about indicating that we're going to have and keeping track of all the atoms so we have the same numbers on one side of the equation as we do on the other side of the equation. And we've learned about this before in our chemical compounds, in our chemical formulas. We indicate the number of atoms of each type of atom with that chemical formula. So for example, CH4 has one carbon atom and four hydrogen atoms. Okay, and then oxygen has two oxygen atoms. So we're reacting what we have on this side of the equation. If we count up all of our atoms, we have one carbon, four hydrogens, and two oxygens. And we're going to do the same on both sides of the equation. So the subscripts that we have in the different compounds, they tell us how many of those atoms that we have in each of the compounds. So remember, we don't put a 1 if we have only one. But every other number that we have, we're going to put a number that tells us we have four atoms in this particular, four atoms of hydrogen in this particular compound of methane and one atom of carbon. All right, so we're going to start keeping track of those atoms. So we make sure that the number of atoms on one side of the equation is equivalent to the number of atoms on the other side of the equation. So for our compounds, there's nothing we can do about the compounds that are forming and reacting. That's the chemistry defines that. So we can't change the identity of what reacts and what is produced. We can't change those identities. So what's in our chemical formula, we have to leave that alone. So then what do we do about having to add atoms to the different sides? So what we do is we add coefficients in front of particular molecules. So we're going to use, whoops, let's get a pen. We're going to use coefficients in front of our compounds. And that's going to indicate how many of that particular compound we have. And what that's going to allow us to do is to balance the atoms on one side with the atoms on the other. So when I write simply CH4, that's one carbon and four hydrogens. What I can do is I can put a coefficient in front of CH4. So if I now write 2CH4, what that's telling me is I have two of this particular compound, two of whatever comes after that. Okay, so I have two CH4 molecules. Now, when I take that number, that coefficient, I multiply everything that's in that compound by the coefficient in front of it. So in this case, when I say I have 2CH4, that gives me two carbon atoms and 8 total H atoms. Okay, so I've taken that coefficient, multiplied it by everything in there. So I'll show you a picture on the next screen about that, but we have 2 of this whole thing, so that means I have 2 carbon atoms, and then I have 2 times 4 hydrogen atoms because I have 4 hydrogen atoms in each molecule. And if I have 2 molecules, that gives me 8 hydrogen atoms. So we're going to use coefficients in front of the compounds, and that's how we're going to start to adjust the number of atoms we have on both sides of the equation. And I want to stress again, we can't change the number of atoms by changing the subscripts, right? If I take H2O and I want to add some more oxygen, if I write H2O2, that's a different compound than H2O. That's peroxide. That's the stuff that you bleach things with. That's a totally different compound. So the reaction that is shown here doesn't create hydrogen peroxide. It creates water. So I can't change the subscripts in order to add more atoms on one side. The only way I can do it is start putting coefficients in front of the entire compound. All right, so let's start talking about balanced chemical equations. So in a balanced chemical equation, the number of atoms on the reactants, over on the left-hand side, is going to be equal to the number of atoms on the products for each of the elements. So I have a reaction here. If you take hydrogen gas, I excluded the subscripts because we're not talking about those right at the moment. We're focused on balance. I take hydrogen gas and I react it with oxygen gas. What I can form is H2O, okay, and that's a liquid. All right, so if I look at this equation, I can see that on the right-hand side or left-hand side of the equation, I have 2 hydrogens and 2 oxygens, each of those in molecules. But on the right-hand side of the equation, when I form H2O, I've only got 1 oxygen and 2 hydrogens. So how can I write it up so I have a certain number of atoms on one side and it's going to be equal to the number of atoms on the other side? Now is where we're going to start using those coefficients in front of our different compounds in order to get the reaction to balance. Okay, so H2 plus O2 gives me H2O. That's our unbalanced equation. That's what the things that are reacting and what are forming. Okay, so we're going to go beyond that. I'm going to go ahead and erase that equation because what we're going to do is go beyond that and start looking how we balance. All right, so let's take a look at that here. So what I show here now is a balanced chemical equation where I've now put coefficients in front of the different compounds. For this one, there is no coefficient, so it means there's 1. And what that allows me to do, and we'll get into how we actually go about doing that, it allows me to balance the number of atoms on one side of the equation to the number of atoms on the other side of the equation. So in this reaction where I have hydrogen gas with oxygen gas making water, what really is occurring is 2 hydrogen gas molecules, so the 2H2O, or excuse me, 2H2, combine with 1 oxygen molecule to form 2 H2O molecules. Okay, so that's the coefficients tell me 2H2O, 1 oxygen, and just so you know, whenever we have one of a species, we do not put the 1 in front of it, and we combine that with 2 H2 gas molecules. So if we take in accounting of all the atoms on the different sides, we can see that on the reactant side, here are our 4 hydrogen atoms, right? We have 2 hydrogen H2 molecules. So if I have 2 of those, that means 1, 2, I have 1, 2, 3, 4 hydrogen atoms. Then I have 2 oxygen atoms from the O2. And on the right-hand side of the equation, the products, I count up all the hydrogens that I have, 1, 2, 3, 4. I have 4 hydrogen atoms and 2 oxygen atoms. So the point of this is, more like I said, we'll get to how we're going to do this, but the point is what I start with this now balanced equation, I have the same number of atoms of each element on one side as I have on the other side. So the same number of reactant atoms is equal to the same number of product atoms. All right, so let's look at how we're going to set up balancing a chemical equation. So what I like to do is, oops, hang on here. I like to set up a little table where I keep track of the different atoms on the different sides of the equation. So I put reactants and I put products, right? And then I write down, go through on the reactant side and count, or not count the atoms, figure out which types of atoms do I have. So I have carbon, I have hydrogen, and I have oxygen. I have those three types of atoms. And that's, of course, going to be true on the product side, carbon, oxygen, hydrogen. Okay, and then I just start to take an account for how many of the different atoms do I have. So on the reactant side, I see I have one carbon atom. And I have 4 hydrogens. Okay, and oxygens, I have 2. On the product side, I have 1 carbon atom. I have 2 hydrogen atoms. And then I got to be careful with the oxygen because it's in 2 different places. So I've got to add up all the atoms. So I have 2 from the CO2, 1, 2, and then I have 1 from the water. All right, so there's just a way of keeping track of how many atoms I have on both sides of the equation. So I can see that right off the bat, I've got the right number of carbon atoms, but I have the wrong number of H2O and the wrong, or excuse me, of H atoms and the wrong number of oxygen atoms. I have 2 and 3 and 4 and 2. So once you've set up your table like this, we start to then make adjustments to the numbers of atoms, and we do that by putting coefficients in front of the different compounds. So right away we see that we have too few hydrogen atoms on the product side. We only have 2 over here. How can we correct that? Well, if we put a 2 coefficient, we put a 2 in front of this compound, now I take everything that's in that compound and multiply it by 2. So when I put that 2 there, what that gives me is 4 hydrogen atoms. And I have a 2, and because I have 1 oxygen, I now have 2 oxygen atoms. Okay, so whenever I put a coefficient into an equation, I have to go back and account for what additional atoms that I've put into there. So when I put the 2 here, now I've got a total of 4 hydrogen atoms. So on my table, I come down here and I say, okay, here's 4. And now I have 2 plus the 2 over here, so I have an extra 1 oxygen atom. So by putting that 2 there, I didn't do anything with carbon, but I added the extra hydrogen that I needed. So that 2 gave me those 4. All right, so those are in balance. Now I'm going to go down to the oxygen atom, and I see I have 2 on here and now 4 on there. So if I've got 2 here, in order to get more on the reactant side, I can do a very similar procedure. I come in here and I say I have 2 oxygen molecules. 2 times each oxygen molecule has 2 oxygens. That's going to give me a total of 4. And that's the only one on this side that I have oxygen, so I didn't change anything else. So now I have a total of 4 oxygen atoms on the reactant side and 4 on the product side. So now, as long as my accounting for all the atoms is equal on both sides of the equation, then my equation is balanced. As a second example, let's take a look at this equation where I have nitrogen monoxide plus hydrogen gas reacts to form nitrogen gas and water. So we want to balance this equation. So we'll have a second example of balancing. All right, let's start with our reactants. We have nitrogen. So let's put down nitrogen. I'm going to move this over. Oops. A little more space. All right, so I have nitrogen, I have oxygen, and I have hydrogen. So I've got 3 different types of atoms on the 2 different sides of the equation. All right, so let's start taking account for those. We have 1 nitrogen, we have 1 oxygen on the reactant side, and we have 2 hydrogens. All right, so on the product side, we now have 2 nitrogens in our compound nitrogen gas, and then we have 2 hydrogens and 1 oxygen. All right, so we take a look at that and we say, wow, we're actually pretty close to being balanced. But what this points out is sometimes when you're balancing equations, you're going to go from one side of the equation to the other, kind of back and forth, in order to get all the atoms balanced, right? So in our equation that we show here, nitrogen's the only one that's out of balance, right? But when we adjust the nitrogen, we're going to see what happens. So let's start with that. We take a look at that. We've got nitrogen here. We need 2 on this side because we have 2 over here. All right, so we put a 2 in front of this compound, 2NO. All right, so that immediately means we get 2 nitrogens, but it also means that we've now changed the number of oxygens. So we have 2 of those. All right, so that's okay. Now we've got nitrogen in balance, but oxygen's out of balance. So let's fix that. So we take oxygen. I see I have 2 on this side and only 1 here. Okay, so that's going to mean that we need 2 oxygens on this side. All right, so let's do that by putting a 2 in front of this compound, H2O. All right, so there's our 2 oxygens that we just balanced. But by doing that, we've now taken the hydrogens and we have to multiply that by 2 also. So we had 2 before, now we have twice as many. We now have 4 on the product side. All right, so nitrogen's in balance, oxygen's in balance. Now we have to go back to the reactant side in order to adjust the number of hydrogen atoms that we have. So we have 2, we're going to need 4 total. So then we take that and we put a 2 in front of this particular compound. And since that is hydrogen, we have, or it's the only compound that has hydrogen, we multiply those by 2 times the 2 for each one of those hydrogen atoms, and we're going to get a total of 4 hydrogen atoms on the reactant side. So now we can see 2 nitrogens here, here, 2 oxygens, 2 in this compound, 2 in our H2O, and then 4 hydrogens, 4 here and 4 here. So we say this guy is now balanced. All right, so that is the general procedure that we're going to use to balance equations. And you're going to see it's going to take, basically, you need to do practice. And lots of practice on balancing equations gets you much better at balancing equations. Okay, so, and in the next video, I'm going to do several more examples, and I'm going to give you some hints and ways to go about balancing equations in the fastest method that we can do. So that will be in the next video.